Should I start again? Okay. Okay. Sorry. Let's move on. So that's how sensor works. Then you have actuators. Actuators are the components that interacts with the environment. I don't have an actuator with me, but basically it's like a component in which you send an input and it can push, you can make a movement. So there are two movements, either push, so going up and down, front and back, or rotating movement. So an example are the automatic door. The one open like this means that it's pushing. The one open like this it means it's rotating. And finally we have the battery. The battery, of course, to make everything work. There are another thing. There are two type of device like this. This one we call it the proximal sensor because they are one next to the environment, very close, in the environment. But also you can have drones. And also you can have satellites. These are also considered devices in an IoT system. What are the challenges when you want to design an IoT device? Well, first you have the power. So the computational power of the CPU. So you want the CPU to have the same computational power or more that it needs in a single, we call it a clock. Imagine like a clock is going like this, and during this movement you have all the sensor getting the information and processing it. So in a single process it should be able to deal with all the sensor, the actuators and components. If they are too much, the data is not the data will be overwritten, so not reliable. Then you have the processing. So you have the processing, and that is about the speed, the velocity of the CPU. So like in the agri-IoT industry is not a problem because plants don't need to have like a fast interaction because we're talking about hours or days in changes. But for example, in industry is very important. An example is the Tesla, the self-driving car. The car the time that passed between the camera catching a man crossing the road and the brake, it must be very little, because otherwise, poor man. Then you have the place. So where are going to install your device? It's going to be in a house, it's going to be on a building, it's going to be on the field, and that's changed like your design. And finally you have the price. You can have the best device in the world, but if it's too expensive for what it needs to do, nobody is going to buy it. And in this little system I see, like these are the devices. Then we have the gateways. The gateways are the bridge between the devices and the internet. Use a gateway every day in your life. That's the Wi-Fi. You don't connect directly to the router, your phone. You connect to a Wi-Fi antenna. And then it can communicate, your device can communicate to the internet. Same way for every network protocol. So if you have different network protocol, you have different gateways. The interaction between the gateways and the device is what is called like a primary-secondary relationship. Old time it was called master and slave. We don't use this term anymore. So basically what happened, So basically what happened is that it's not that the device are sending the information to the gateway and the gateway is sending to the internet, but rather is the gateway sending a request to the device are passive listener and they send it back a response to the gateway, and the gateway is using a file called a packet forwarder. It's sending the message, the data it gets from the device next one. So we have the connect. Okay, this is it's about ICT. Anybody study ICT? No one? Okay. Here, there are some people studying ICT. Okay. There are some students. Okay, so this is like a huge like topic. So I'm gonna like be very superficial about this. So basically, what you want, it depends on like the relationship between the gateway and the device, and the gateway and the internet, and some physical constraints. You develop a different like structure of your of your model. So the first thing you want to know is the topology. So it's like the relationship between the device and the gateway. Usually in agri-tech we use it, but like 90%, 99% of the IoT system use a star system. So you have the gateway in the center, and the device are connected to a single gateway. Then you have the structure: one man LAN, one area network. Medium area network, local area network. A MAN is basically the internet. So if you connect to a server like abroad, you're using a WAN. It's another way to call it the internet. But also in IoT you can have also LAN. You can have everything local, like in a single building, in a single place. Then you have this end rule for the physical constraint. So, and this represent from this graph here. So you have the thumb is the bandwidth, so the amount of data you're sending. If you're sending a text file, the bandwidth is gonna be very low. If you're gonna sending like an image, the bandwidth is gonna be very high. So it's moving up and down the Y. And then you have the range, so like the distance between the physical distance between the device and the gateway. And if you increase one, if you increase two, the other is increase the amount of power of energy it needs to establish a good communication. So what happens if you have like a high bandwidth but a short distance, like a Wi-Fi, you're here. In agri-tech, usually we have low bandwidth because the sensors are sending like values, so text file. So you have low bandwidth, but a very long distance because maybe like the gateway it's on the office and the field is like 2-5 kilometers from the office. So you have a long distance, and therefore we mostly use LoRa. Then you have to decide if you want a license or an unlicensed, and that's like in regard cost. So for example, if you use a phone provider, is usually a license because you pay a fee for calling for the internet. But you also have unlicensed like Zigbee, Bluetooth, LoRa. Here there is like a catch, there is like a problem, and that's the problem of interference. So if you use a license, it's usually regulated, so you are sure that your communication is not going to be mixed with other communication in the same bandwidth, because you get like a specific bandwidth. In an unlicensed is anarchy, so basically you need to make sure that your system is not interfering, is not using the same bandwidth frequency. It's not using the same frequency, of another system in the same area, because otherwise the data is gonna mix up and it's gonna be unreliable. And that's about the communication between the gateway and the device. Then you have the communication protocol, the messaging protocol between the gateway, so once you receive the message from the device, and the server, so through the internet. When you navigate on the internet, you use HTTP for the protocol. The HTTP version for IoT is called the MQTT. The MQTT is lighter than HTTP, so use less energy, is more energy efficient, and also it allows to do this, I think I call it subscriber broker protocol. Which means that the MQTT comes with a file that it can establish some rules to make like a sort of automatic process of this sending message. So for example, you can have like a system that a device needs to send a message every 10 minutes, another device needs to send a message every hour, another device need to send the message once a day. So you can, with MQTT, you can establish easily this. But also you want, for example, one device to go to the cloud, another device to go directly to the server. And you can do this with MQTT easier than with HTTP. And then just to make understand how it works, how machine to machine is different to human communication. So they use like not the decimal, but use the hexadecimal system. So basically it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. F means 16. And that's make it easier. Basically like you compress a message into fewer digits. And that's the machine can read it easily. So like your job is to, if you want to do IoT, you need to like decode this message. Next one. So now collect. Now that you establish a connection, okay. Now that you establish a connection, you have your data flow in. You want to organize this data. So when we talk about IoT, we only talk about big data. Big data are described with the 3 V's. So we have volume, so a huge amount of data. You have variety, because data can be different, so like the payload, the single datum coming from different device can be different. If you have a weather station, maybe with 5 sensors, you have a different like row from in an Excel file, let's say. If you're having like from this Dragino, there is only like 3 values coming from here. So there are differences. Or if you have like a camera, there's an image, it is not text. So it's the database hosts a different type of data. And then you have velocity. So for example, you have like 100 devices sending every hours or every 10 minutes. At the end of the day, you're gonna have a lot of data coming in, and the next day you're gonna have a lot of the same amount, a lot of data coming in. So the velocity of the data flowing in is very high. So that's how you describe big data. So we can't use the old SQL, the classic, the traditional programming language to deal with database when you have this kind of database. So we don't use SQL, we use NoSQL, that stands for non-SQL or not only SQL. That allows to like work with this unstructured data, so like big data with different type of data in the same database. So you want to consider 3 things to make a good data governance. First is the data management. Data management, like you have 2 approaches. The first one is called the data silos. So imagine like a water pipe and it's leaking, and inside the leak you put a bucket. That data silos. So basically, like for example, you want a very easy example is I want within my company everybody to get access to all the data. But I have client that only wants to get the data they need. So basically, like there is one bucket that is getting all the data. The bucket of my client is getting like some part of it filters some data and it gets the one they want. This have a problem that if you want to change and you want to, for example, have like another client to get access to some other client data, you cannot do it because it's like you need to reprogram the structure of the database. So in order to solve this one, if you have this case, you use data lake. A data lake is imagine like a lake, you go fishing. So basically you have a single container of data, and through a set of rules, they can fish, they can get the data they want. The client, they can get the data they need. Then you want data ontology. Data ontology invented by Tim Berners-Lee, the inventor of the internet.
It's a way of linking data to context and concept in order to give a meaning, to give a context to the machine. So basically, like we use it now, the standard is a JSON file. So a JSON file, it's like a file in which you can link a value to a name. So you can create a relationship between like the numbers, the single numbers, with like a reference. So the machine can understand that if you're talking about temperature, or if you say 33.7, it means temperature. So it means something. And that's very important to do, for example, artificial intelligence. Then you have, sorry. Then you have the last one is the semantic. The semantic is actually a preliminary work, and that's establish the relationship between the devices. So it's just a graph. It's just a graph. It's not like any programming work you do. You say, for example, device 1, it's connected to gateway 1, and device and the actuator 1 is connected to gateway 1, and so on. And there are two ways to describe. It helps you to understand, to describe the system you're developing. There are two ways. There are the SOSA, so stand for sensor, observer, sample, actuators, and it's object-oriented. So like device 1 as actuator 1, open door 1, and so on. Or you have the SAREF, so the smart application reference, and that is place-oriented. So device 1, like smart lighting, device 1, it's ground floor. Device 2 is first floor, something like that. Okay, so next one. Okay, we have the learner. How much time? Okay, still. We have the learner. So once you have the data, you have a good governance, and the data are clean. Now you can do something with this data to extract value. So of course, the first one, as I said, is AI, but the first one is easiest one is the data visualization. So you can represent the data you're flowing in with a graph or a pie chart, or anything you want. That's like the simple things you can do with your data. Then you can have actually the BI. So a BI stands for business intelligence, and that's it's a software, a program that can create an interactive map. So imagine like a website in which the user can interact with the graph by changing the data. So it can assess the database, and it can make changes in the queries. So for example, I don't know, you have a temperature graph, you want to find a relationship with the rain, so you can like interact with your system, with your database from a user point of view. And finally, you have AI. So AI, as I said, is like you have all this data you want to extract like a value. For giving an example, we are working on. We have data from the climate, and we want to find a way to understand if a field based on like humidity and temperature is developing a bacteria. So like our final product, it will be like an index saying the field has a low probability of developing this bacteria, or have a high probability of developing this bacteria. So you take a huge amount of data and you reduce to a single things, like a single value. So at this point, we are on the cloud. So here happened the virtualization, and you transform your payload machine readable value into something that you can read. Sorry, you can't really read here, but here is like the alphanumeric value, and here you have battery, rain, and so on. So what you can do with like all these tools, you can do two things. You can create a DSS. A DSS stands for a decision support system. So a system that can support the client on taking decision. Like I said, our example with the bacteria. So basically, you have you want your client is a farmer and he doesn't know if it's a good time to like put the product or I don't know, open the irrigation system, and you give like some insight, some more data to take the decision. That's a decision support system. Or you can do like some automation. Or then you can do some automatization. So for example, an irrigation system, you can have for example, this one is the soil measurement. It can get like the amount of humidity. So when it's dry, it can open the irrigation system automatically. So, and that's the last one is the do. So once we have all this tool, we want to like present all this tool to the client and have a product to sell. And so you can create like a platform, a software, a website. There are many possibilities. And generally, like what can you do, especially in the agri-tech an agri-tech product, usually you have a large system or suggestion. So like sending an email or sending a message saying, look, there's a problem here, or like look, like the price of this is low, so it's better to buy this. Then we have the interaction, so like you can create a website, so you can navigate, or an app, so you can monitor your farm. The farmer can monitor the farm from like when it's at home, anytime from the phone. And you can also access historical data. So for example, I don't know, the harvest is less than last year's. What happened? What changed from last year? Let's check the historical data. All the things can create an improvement. So like you can have you can reduce cost, you can have better quality, and you can change your production system to like be more efficient. And we have also, since it's like a digital technology system, of course you have the problem of security, because it's subject to bugs that will change also. If you have a DSS with bugs, it probably give you like a bad suggestion. If you have a malware attack, so you need to secure from attack from like hackers and so on. Okay, so we finish like this is how generally an IoT system is. It's a lot of things. There's no fixed rule. You can. Imagination is your limit, basically. So let's take an example of a use case of Castelvatica, where I work in Italy. So this use case, a rural area in North Italy. We have a farmer that is producing milk and is medium size, and what they want to do is to monitor or improve the fodder. So the feeding of the cows that they produce inside in their farm. So this is the case. So here is the farm. We have the field here. The office are here with the internet connection. So we put the gateway here, and we have the sensor here, and the distance is 1.5 kilometers. So this is the things. We have some batteries like the long distance. We don't have energy supply on the field. The type of data they want to monitor is just text, so low bandwidth. So we choose the gateway is the Resiot X4 and two sensors, a weather station and a Dragino LSP01 that it's like it monitors the soil, so it gets the pH, the humidity, and the temperature of the soil. Same for the connection. So the shape is just a single relationship between the device and the gateway and device. They're not communicating between each other, so it's a star shape. we communicate to the internet, so it's a 1, and the features are low bandwidth, and of course MQTT. So that's why we choose LoRaWAN, because if you remember the hand rule, so we are on the part of the LoRaWAN. This is the some of the data that we collect, so from the weather station, some data inserted by the farmers, phonological stages is like at what point of the harvest we are, what treatments we use on the field, which culture cycle we use. So what we have done so far is like payload and virtualization of the data flowing in, some data visualization, and of course we are working on the BI and AI model to create a DSS, so an alert system, and maybe, like in the future, maybe we can have some automatization. And that's how it looks at the website, basically. So that's how, from the farmer point of view, you can check, here the temperature, or the rain, or the dewing point. Okay. Finally, I want to talk very fast, last 5 minutes. So I see that you're already tired about the prospect of IoT system in Indonesia and the benefits of implementing IoT in the agricultural system in Indonesia, also here in West Kalimantan. So first one, I want to say that IoT in Indonesia already exists, especially on smart cities. Because we have, for example, Jakarta, it's a smart city. So you already have the capability, you already have the knowledge to invest and to implement this kind of system. So you already have use case here in Indonesia. Second one is that it can improve production. So as I said, it can reduce the cost, you can use less product. For example, fertilizer are very expensive. So if you want to use fertilizer, you want to use it in a very efficient way, and IoT system can help you on this. You can change also your production to increase the quality, and all of this it can boost competitiveness of Indonesia in the global market for coconuts, but not only, like bananas, palm oil, like anything. Then another indirect benefit of an IoT system, it's cooperation and development. So cooperation, it means that you can create, you can improve the communication between the central government and the rural area. Because imagine if you have the farmers in a rural area checking their system on their phone, and through that system, you can send, for example, best practice, you can update on policies, you can send an email or send notification saying with some communication from the central government to the farmers, and so on. And also development, because if you implement an IoT system, you create a new specialized job. Because you need IoT architects, you need a communication technology expert, you need web developer, you need a cybersecurity expert, and so in order to manage this system, because they are automatic, but they need some day-to-day work to make it work properly. So you can create job, and that's create also economic growth. And finally, the last one is climate change. You know that climate change is affecting everybody, and there are gonna be some more extreme weather events in the future. IoT system, it can help prevent, not prevent, but monitor and maybe understand that whether an extreme weather condition is coming, and maybe you can save some of the production in the area that is subject to the weather condition. I give you an example from Italy now, but last week there was an extreme flood in my area. Some towns, they also have 2 meters, 3 meters high water flowing in. And they estimate that it's a rural area with a lot of small, medium-sized farm. And they estimate that the damage from this flood it's estimated to be 1 billion euros, so 100 billion rupiah, just for this flood from last week. So IoT can help like reduce this amount of damage and maybe like not only save the people's life, but also save the work of the farmers. Thank you. Finish.
Okay, let's get applause to Mr. Lucky. Thank you very much, Michael. Such a great presentation and detailed explanation. I hope you all in the audience can understand what Michael said. Atau ya perlu saya simpulkan sedikit. Mungkin I'm not a yeah.
Just one last thing, like if you want, I can give you my email. So if you have any question, if you don't understand some things, or if you want to have some more information, feel free to contact me. I will give you my details, my contacts.
Oke, katanya kalau pengen chatting, nggak kalau butuh informasi lebih lanjut ataupun butuh pertanyaan lebih detail, silahkan hubungi Michael Angelo by email. Nanti akan ditampilkan Pak Beng sebentar untuk yang slide terakhirnya. Nah itu yang di bawah itu. Ada Michelangelo mdgrandis@agridecision.com. Ya. Oke, nanti bisa ditanyakan ke LPPM. Oke, jadi tadi itu pemaparan tentang IoT. Jadi memang IoT ini merupakan teknologi yang sebuah paradigma teknologi yang pada saat ini sedang sangat berkembang. Jadi bagaimana IoT ini bisa mengkomunikasikan, mengkolek, kemudian dianalisis untuk kita melakukan sesuatu yang kita butuhkan. Jadi tadi seperti Michael sampaikan, ada komponennya apa yang kita perlukan. Tentunya wilayah-wilayah yang ada itu memiliki tantangan sendiri. Mulai dari sinyal, kemudian mulai dari electricity-nya, kemudian harga barangnya itu sendiri. Kalau mau lebih kuat, lebih detail ataupun sinyal yang kuat tentu sesuai dengan harganya. Kemudian bagaimana langkah-langkahnya kita mulai dari mengkoneksikannya, kita perlu jaringan internet. Kemudian bagaimana kita mengumpulkan data-datanya. Kemudian data-data itu kita manage, kita kelola. Ada satu wadah data yang besar, kemudian kita ambil data-data yang sedikit yang kita perlukan. Nah kemudian kita gunakan data-data itu sesuai dengan kebutuhan kita. Untuk apa saja? Diaplikasinya untuk bisnis kah, untuk perikanan kah, untuk dan semua bidang yang ada di tempat kita. Nah kemudian dilakukan untuk apa? Untuk perbaikan, untuk keamanan, ataupun tadi seperti Michael sampaikan tadi setelah terjadi banjir di wilayahnya, dan ini bisa membantu mengantisipasi keadaan bencana juga, dan juga digunakan untuk tadi peningkatan produksi pakan untuk petani yang ada di Italy. Okay, let's move to the discussion session. Is there any related question to the topic IoT for smart farming or IoT in general? Please, one or two questions from the audience here. Anyone? Just simple question or?
Was crystal clear.
Or it's crystal clear, Michael said. Now I have two prizes here for the first two questions. Anyone? This is a great prize. Anyone? You can ask. Oh yeah, Mrs. Silakan. Gak apa-apa kalau mau Indonesia nanti saya translate, tenang saja. Ya, silakan. Tunggu mic-nya ya.
Uh, Thank you. Good morning for the speaker. I think it's nice topic that you get to us. I want to know what do you think about the progress and development of Indonesia's agriculture? Because I want to know what your opinion deeply. And maybe you can give some suggestions about how to improve our agriculture. Thank you.
Okay, thank you. You got question?
Okay, honestly, I'm not an expert on the Indonesian agricultural industry at the moment. We've been to the farm nearby. We see, from what I see, is that we have like a lot of small farmer. I don't know the presence of like big industry. Of course, like the problem with the small farming is like the process they have, because maybe they're more traditional, but that's like typical of the agricultural sector. It's very conservative. So like for example, like let's say the example of Indonesia, there are already the cases for smart cities. A smart industry, but smart farming is not developed. That's also like because the industry is very conservative, but for a good reason. Because when you change the production method, you also change the taste of the final product. So maybe if you find if you are okay with the taste of your final product, you don't want to change the production method. You want to maintain that one. But that's like a general problem in the agricultural industry. But also it's a huge opportunity, because if you find like people adapt to taste. So if you implement new way of producing, also the people will adapt to a change in the flavor, in the taste. So I don't know if it's the same here, but like in Italy, like old people complain that the fruit doesn't taste as they were kids, but that's because like they start using less chemical product. So like there was a change, and like our grandparents prefer the one with a lot of chemical toxic product instead of like new biological sustainable products. But that's like because like you when you grow up, when you are kids, that's when you get all your taste first, and you get used to that taste. So if you grow up and that taste change, you're gonna prefer the one when you were a kid, not the one now. So that's why, for example, the industry is very conservative. But I think there is like a huge opportunity, because all the trade-off is gonna be offset for the fact that the farmer can be helped a lot, as I said, in the communication, in taking decision. It can reduce the cost. It can prevent some problems, so like disease. It can prevent extreme weather condition. So there's a lot of benefit from this one. Another problem with the fact of having like a small farmers is that they are less. They don't have the money, like for example, a huge corporation. So a huge corporation, you can invest a lot of money on an IoT system. Maybe like a small farmer doesn't have that much money. So probably like you also need some government intervention, some government help to facilitate the implementation of this system. Okay, was clear enough? Perfect.
Thank you, Mr. Michael. Ya, gimana, Mrs. Iin? Ya, tadi banyak sekali penjelasannya. Jadi untuk pertanian kita mungkin yang masih tradisional, ya mungkin dalam improvement metodologi ataupun kita bisa lebih membantu ke petani untuk memperbaiki, meningkatkan produksinya, mengantisipasi bencana dan lain sebagainya. I got another question from my friend from the Zoom application. He's doing her PhD now in Japan. He's now in Japan. Please elaborate some examples IoT that has already applied for health promotion in Italy. Do you have some information?
Health promotion.
Yeah, applied for health promotion.
Health promotion in Italy.
Yeah, that might be can be applied in here.
Okay, actually, you know, Italy has this problem that we are really good. We are really good after the after the damage is done. So like we don't prevent. We usually fix the problem after. So actually, I don't know about an health promotion before COVID, but probably after COVID they are start implementing some system. An example in particular, I can't really tell, sorry, because my specialization is agriculture, not health. But for example, I know for promotion, but for example now you have you can see more and more, for example, their glucose checking. So basically, in past, they use use a syringe to extract probably something from the liver, and then you can analyze and see the amount of glucose. Now you have these things that you install, and it's a sensor that detect the glucose, and you tap it with your phone, and I give you the amount of glucose. So now you don't need to use a syringe every time. So that's, for example, I think that you can see more and more. But also if you're deaf, all this system that install in your body, you start seeing more and more not cyber thing, a very simple stuff. But you can see more and more now.
Yeah, I forgot something. For Mrs. Iin. Please give her the prize. Okay, give applause to Mrs. Iin. Don't forget to take the picture. Asal jangan cipika-cipiki ya. Okay, one.
Can I ask you a question? Who's interested in working in IoT?
No one. And they are still confused. Okay, one more question, the last questions, because we have the limit time. Okay, the last question, one question, anyone? Or from the Zoom application, or from the Zoom? Is there any question? Okay? Yeah?
The negative impact of IoT, the components for example, the components you're using lithium-ion batteries. You need to dispose all these batteries. You need to extract the batteries. The chip they use all the rare material, rare earths that decompose the chip. Of course, in the future, that we think that we are gonna use more and more this system. So I think already now there are 10 devices for every person in the world. So we have almost 100 billion, if you count also the phone, the satellites, and everything. if you count that we are going to use it even more of these devices, the extraction of all these materials is going to be finding also this material is going to have a huge impact. So that's why you also need it's very important to be cost efficient, but not just because of the cost, but because the cost represent the material. So you want to reduce the amount of material used. So for example, you don't want to have a very powerful, too powerful for the needs of a computer, because it needs to use more material, and if that material is not even used, it's a waste, it's a bad impact. So I think this one is the major problem, is the major impact on this one.
Oke, tadi dari Mrs. Elita, he's my friend from the other university in here in Pontianak. Tadi artinya adalah dampak negatifnya mungkin kita akan terlalu banyak akan menggunakan gadget dan segala macam dengan materialnya yang mungkin ada beberapa yang ekspensif karena material-material yang jarang kita temukan, dan dampaknya juga kita nanti akan lebih produce sebanyak-banyak material dan akhirnya akan menjadi waste juga ujung-ujungnya. Oke, mungkin itu saja dampaknya, tapi lebih ke banyak ke the advantage of IoT that they can help us for anything that happen or our activity, our study or anything to the development of the countries and the governments. Okay, and we are going to the end of the event, so thank you very much for Mr. Michelangelo de Grandis. Yeah, it's hard to say your name, long name. Okay, mudah-mudahan I hope this kind of transfer of knowledge can help us to more understand about the IoT and the function and the advantage for the development of our study or our government, especially for our society. Okay, thank you very much for the audience from the room in here, and give applause for all we here, and then thank you so much for the audience from Zoom application, and then the last session is we get picture, to take picture here together. Maybe you can stand in front of here, and the camera is here. Okay, and then I close for this event. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Oke, semua berdiri. Nanti Michael di sini. Nanti foto dari arah sini ya.